Hi, we're here today at Indicate Technologies in Santa Clara, California. That's in the heart of Silicon Valley. Indicate Technologies is a distributor of precision metrology equipment. With me today is John Hammond, president of Indicate Technologies. How are you doing today, John?
Just fine, thanks.
So what's on the agenda today?
Today, Dirk, we have more of a conventional CMM that's equipped also with a laser. It's by Metris LK, and it's an Ascent model 1076. And we're looking at this part here, which is a aluminum control box. We were going to kind of give you a tour through a couple of things today. One might be the reverse engineering of this from a part, creating a CAD model.
Okay.
And then the other would be to inspect a part back to the CAD model.
Focus Scan is the name of the software?
Focus Scan is the name of the software. Another interesting side note here with CMMs is with the movement to multi-sensor machines and away from contact probes, there's been a generational change in the need for the performance of software. The traditional GD&T software that's out there on everyone's machine does a great job with contact data, and when it comes to the quantity of data that's usually generated with sensors such as lasers, those softwares tend to start to feel their limits of their capability and their performance of handling data.
Because of the amount of data?
Because of the amount of data. So this Focus Scan software, its strength is in its ability to handle large data sets and to structure the flow of the work for an inspector on a simple step-by-step basis.
Okay, well, show me how it's done.
Because we have this laser sensor mounted on a PH10M, which is an articulating Renishaw probe head,
okay,
it gives us the ability to reorient the sensor in the volume of the machine and to acquire the data from different orientations. Okay, well, Brian's actually worked up a macro here, so why don't we have him run through that and give us a little narration about what's happening while that's going on.
What we're doing right now is there's going to be 3 different scans. One's going to be the top view, and then we're going to take 2 side view scans. It'll go in multiple different sections across the part with a bit of overlap. The reason you're doing the overlap, obviously, is to make sure there's no missing data.
Okay, so this is a scan as it's actually happening. Now, how fast does this scanner scan a part?
It can scan fairly quickly. It's all dependent upon what spacing you want the stripes to be set at. Right now, I believe I set it at 30 micron spacing between the stripes.
So I notice we're just moving just right across, step by step, right across these tabs.
The way that the focus inspection is set up is with this workflow scheme where you have pretty much you just click from the left to the right, and you go through the different steps, and it's pretty intuitive to figure out what's happening.
We're on the nominals tab now, and Brian's read in or loaded this CAD model. And this is a point cloud. In the case where you're looking to capture a lot of data on a surface, it's a powerful way to go. So after creating a point cloud, we'll step to the alignment tab, which now will allow us to register the data points to surfaces. Generally, the way we do it is we get it close, and then we ask the system to do a fit of the data set to the CAD model. And this picture here represents the data after it's been fit to the CAD model. So once we have this, we're ready to essentially query this model to extract the information that we're interested in. Here, Brian has generated a number of flyouts of the material condition at those particular locations relative to the CAD model. So essentially, all the data has been acquired and registered to the CAD model,
okay,
and features can be extracted and reported on.
And what you just showed us, if I understand correctly, then this is how you would do. This was how you would do inspection. From what I understand, you can use the same kind of variation of the same process to do reverse engineering. So basically, takes us full circle. You could scan a model, create a CAD file out of it, and then later on during production, take that CAD file and use it to actually do the inspection on your production parts.
Exactly. There's definitely multiple uses with the system, and between the touch probe and the laser, you can accomplish quite a bit.
Okay. Well, thanks. I appreciate that. All right.
Thanks, sir.
Okay. Thank you.